This is a Xiao RP2040. It's called a microcontroller, a little computer that you can program to do certain things with sensors and actuators and stuff like that attached. This and its sibling, the Xiao ESP32, are really taking over the DIY project market right now. If you're making a project that requires a microcontroller and you're not using an Arduino, you're probably using one of these. It's pretty easy to use and super small. And not only that, it costs only about $3.50, which is crazy. It makes you wonder how these things can possibly be so cheap. So I toured a SEED research laboratory and factory in Shenzhen, China to find out how these things are made at such low cost. I also learned some other stuff like how they make these things and why they have a wind tunnel. I toured with the CEO of SEED, Eric Pan, and the founder of Hack Club, Zach Lotta. So let's get into it. So first of all, this isn't actually where they make all the Xiaos. They make so many of them that's handled by a larger network of manufacturers and distributors. But the building I toured was actually way more interesting than that. So this is a place where they research new products, but they also make small batches of stuff. And you'll see what I mean when I get there. So we get inside and we're just met with hundreds of robotic arms being assembled. Just rows and rows of these things at different points of assembly. And this brings me to my first point about how this thing is so cheap, which is the scale of parts available in Shenzhen, China. How far away do you know is the print farm that makes these printed parts?
I think it's less than 1 hour.
Really?
Yeah. All the parts for this machine, the motors, the 3D printed parts, the cables are within 1 hour's range.
And I experienced this a lot when I went to Huaqiangbei, which is like a huge electronics market in China. There were as many types of electronics parts as I could think of in this place, and they were all available just right there for me to grab. Contrast that to the United States, where you have to order things online. There's no local alternative. Part of the reason these are so cheap is that there are so many parts available for these products locally. So now it was time to go upstairs, where they actually put PCBs together. Now a PCB is made up of two parts. You have the board and then you have all of the components on top of it. The PCBs were manufactured somewhere nearby. The components, the assembly, what's called PCBA, that was all done in-house in this factory. And they did, again, like the robot arms, small batches of things that they were selling.
The PCB will go into the solder pasting machine. To apply the solder paste, it's like glue onto the PCB on the right spot. So that's where the solders has been applied like. So they have to be very fine pitch, very small, very precise. Then afterwards, we put the components onto the baseboard. Before that, they do the AOI, which is to do the optic check if it's running right. Then the machines will put the components right onto the spot.
How many individual components are on a Xiao?
Around 100.
This is sucking components up from here and putting 100 individual unique components on this.
We buy from all kinds of vendors all over the world. So a lot of them, they have their distribution channels in Shenzhen, so they arrive the same day.
After all the components are placed on the board, they come down on this conveyor belt and go into this multi-stage oven.
So it's very much like your oven.
Yeah.
You have some preheatings, you will warm it up, and you have some peak hours, and it's slowing down. Yep. So with 8 to 10 different temperature zones, you can control it more precisely.
Yep. I really like how your oven runs Windows XP.
No, I don't like it.
This is a pretty special one that Eric has, like a CNC machine for soldering.
So because a lot of soldering is either by hand soldering or by wave soldering, it's like CNC. Like it will just touch wherever it needs to be soldered. It's called a selective wave soldering. This is my favorite machine.
This is my favorite machine.
It feels like a forge.
Now, something that I want you to notice is that nearly all of these machines have a skilled operator that's using it. Either they're looking at some screen to make sure it's doing everything right, or they're directly controlling it, or they're soldering things by hand that can't be done by a machine. And this brings me to my second point of how these things are made so cheaply, which is that in Shenzhen, there is just skilled labor everywhere.
And how many people work in it?
Maybe 80.
How do you find them?
For factory workers, it's easy. The scale is also about talent scale. How many people are still doing manufacturing day to day and understand the details?
And the fact that there's just such a huge number of people willing to work there means that this stuff can be made cheaper. And I think that the globalization of engineering skills is very important. Hack Club, the foundation that Zach founded, is actually trying to bring engineering abilities to teenagers all over the world. And if you're a teenager between the ages of 13 and 18, Hack Club is running programs that you can take advantage of to get free engineering supplies or go to a hackathon for free. If you're watching this before October 2020, 26th, they're running something called the Star Dance Challenge, where you can get prizes and funding for building stuff. And you can check that out here. Otherwise, just go to hackclub.com and see what's going on. Okay, so next we enter this room with just a guy and a big, loud machine. And Zach asks,
What is this?
Wind tunnel.
Oh, what are you testing?
With your stations, they have wind sensors. You need to calibrate every of the sensors in different winds and directions.
And you wanted to make a weather station.
Yeah.
To manufacture it, you had to build a wind tunnel.
Yeah.
Oh my god, that's crazy.
But across China, you see a lot of specialized machinery like this one.
okay, now we're gonna loop back to the robot room. Because here Eric told us about the most important factor in making the Xiaos so cheap.
Today you get like this aluminum rail right here. You need a special one made. Today you CAD it. How long until you have the first one made?
Depending on the price you pay, it's not about the waiting of time, it's about priorities. You pay higher price, you get it the next day. $100 for example. Just assume it's very fast to produce. If you need 1 week, maybe $50.
And this actually conveniently brings me to my third point of why these are so cheap, which is incubation. When a product is in the incubation stage, that's essentially just iterating it. You're making it and then making it again and again with different designs and different parts every time. Let's say I'm in the US and I design something, a new circuit board. I realize that one of the chips is the wrong kind of chip or not fast enough for what I need or doesn't meet the right specifications. If I want to integrate a new piece into my board, I have to order that piece, wait at least a few days for it to get delivered. If you're lucky, probably more like a couple weeks. And again, if this is a custom part, you're probably ordering it from China because custom PCB and CNC parts are just cheaper from China. And finally, after that amount of time, anywhere from 2 days to 2 weeks to maybe more, I can integrate this new part into the product that I'm developing and see what's wrong this time. And again and again. The product incubation is so inefficient when you're making something in the United States because we just don't have things manufactured here. Now, let's do the same thing in China. There's nothing that you couldn't get same day, even if it's a custom part. And so this third point, the fact that it's so fast to develop products, kind of feeds from the first two. Not only do you have so many parts available to iterate with and so many skilled workers that can iterate your design, but also the fact that it's designed so quickly means you spend less money on R&D. Thus, the product by the end is a lot cheaper. But yeah, I think the Seed Factory was super fascinating to see, and I hope I was able to give you a little bit of that. So if you're a teenager that's interested in engineering, you should check out Hack Club. If you're watching this before October, you should definitely check out the Star Dance Challenge, where you can earn prizes like a 3D printer or a laptop or fudge or filament. And if it's during or after October, Hack Club is definitely putting on something just as cool. And I'll see you later.